right, guys, we're going to do 2 more questions regarding solving quadratics by completing the square. Again, I need to solve this quadratic by completing the square because it's not factorable. If I try to do diamond method, there's nothing that multiplies to -5 but adds to -2. It doesn't exist. So we need to use completing the square. So remember, the first step is to move the constant to the other side using the opposite operation. Once that's moved, we leave a little space here. We add those to get 5. Now remember, if I'm completing the square on the left, I need to complete the square on the right. To complete the square, remember, I take half of the b value, that middle term in front of the x, just the coefficient. I take half of that, so half of -2 would be -1, and then I square -1. So that would be -1 times -1, that would be a +1. Remember, it's always positive when you complete the square. So now that I have +1, I would add 1, and then whatever I do to the left, I do to the right because I have to keep the equation balanced. Next, what I do is I factor the perfect square trinomial. I factor it using diamond because it's a trinomial. So if I'm going to add to 1 and multiply to -2, I'm going to be, I'm sorry, I did it backwards. I'm going to multiply to 1 and I'm going to add to -2. So I'm going to be 1 and 1, but since I'm adding to a -2, they both have to be negative. Negative times a negative is positive, and they add to a -2. So I'm going to write it as x minus 1 times x minus 1. But remember, anything times itself is squared. So that's really x minus 1 squared. All right, so that's that side. Now this side I can just combine. So that gives me 6 on that side. So I get x minus 1 squared, the quantity of x minus 1 squared, equaling 6. I have to get x alone in my last steps. So in order to do that, I need to square root both sides. The square and the square root are inverses of one another. Whatever I do to the left, I do to the right. So I'm left with x minus 1 because the square and the square root are gone, equals, now the square root of 6, remember every square root has a positive and negative value. So it's really plus or minus the square root of 6. All right, I have to put that plus or minus in front of my square root or radical. Once I'm done with that, I have to isolate x. I have to get rid of the -1 by doing a +1. All right, so to remember to write my answer, I write it as 1, positive 1, plus or minus the square root of 6. If the question is asking for the exact value of the solutions, all you can give them is 1 plus the square root of 6 or 1 minus the square root of 6. The reason is the plus or minus. So these are the exact answers. Remember, most quadratics have 2 answers. These are my 2 answers for this quadratic. My approximate answers are found by putting the exact answers into your calculator and getting decimals. So if I were to do 1 plus the square root of 6, that would be my approximate value, about 3.4-ish, right? Depending upon what they want you to round to. We'll round to the nearest 10th, but you'll round to whatever the question asks for, depending upon what they're asking, whatever assignment you're doing. Now I'm going to do the exact value of 1 minus the square root of 6. So that would be -1.4 approximately. So that would be my other approximate answer. So if they want the exact answers, it's 1 plus the square root of 6 or 1 minus the square root of 6. And then my approximate answers are 3.4 or -1.4. Those are our solutions. Again, they're not rational numbers because this equation was not factorable. All right, here's one more example. Again, let's follow the same protocol. We have to move the constant value. So we're going to add 9 in this case because it's the opposite of a -9. I'm going to leave my blank space on both sides. I have to complete the square. So remember, take half of the middle term. So half of -2 is -1. Square -1, you get 1. -1 times -1 is +1. So a +1 is what goes in the blank space. Whatever I do to the left, I do to the right. I now factor this. This was actually the same as the other one. It factored as -1 and -1. So remember, that's negative 1 squared, x minus 1 squared. Now I'm going to combine like terms on this side and get 10. So now I'm here. I have to make sure I rewrite this squared. All right, these have to always be the same. They have to be perfect squares. That's the whole point of completing this square. Once I get here, I have to square root both sides to get rid of my square so I can get closer to my x. Whatever I do to one side, I do the other. But remember, the square root of 10 always has a positive and a negative square root. So this plus or minus is crucial here. All right, I'm almost done. I almost have x alone. I just need to add 1 to both sides to undo a negative 1, and that will give me x alone. So remember, x equals 1 plus or minus the square root of 10. In many cases, you can submit your answer just like this. All right, just like here, you could submit your answer just like this. But I just want to, again, demonstrate the difference between the exact value and the approximate value. The exact value of your answer is 1 plus the square root of 10 and 1 minus the square root of 10. Those are the exact values. But a lot of times we want to know approximately what that equals. So the approximate value would be found in our calculators. 1 plus the square root of 10. All right, so that's approximately 4.2, right? 4.16 would be approximately 4.2 if we did it to the nearest tenth. And then the other value we would find by doing 1 minus the square root of 10, which is the other exact value. That's about negative 2.2. All right, because it's negative 2.16, so the 6 turns the 1 into a 2. So those are my approximate values, and those are my exact values. But most of the time, you can just give your answer that way.